Okay, so we discussed velocity, the different types of velocities, and acceleration, and even moved into free fall. And so now what I want to do is put them together. Put together horizontal motion with combined with vertical motion, which we would refer to as projectile motion. So in projectile motion is when an object follows a curved path. So even if you throw a ball, the ball may go up and out, but eventually gravity is going to pull it down. It'll follow a curved path, and that curved path is called a projectile. Now, to keep things simple, when we fire something or throw something or launch something, we're going to do it on a straight horizontal, so we don't have to worry about the trick. Okay, we're going to keep the math easy, but we're going to put these two concepts together into one larger concept. So, just to review, we talked about constant velocity, and d equals vt works really, really well if you're moving at a constant velocity, or if you use an average velocity, that works really well. But once we put gravity in the picture, in the instance of free fall, your velocity starts to change. Now we could freeze this ball on the way down. It would have an instantaneous velocity, the velocity at that moment in time. But as it falls, it accelerates towards the earth. Same thing if we throw it up. We'll throw it up with some velocity. As it goes up, it slows down. It comes to a complete stop, turns around, comes right back down. Now, the acceleration due to gravity on Earth at sea level, ignoring air resistance in a vacuum, et cetera, is about 9.8 meters per second squared on Earth. Assume we're on Earth unless I specifically say we went to another planet. Now, as I drop this, the velocity increases, but the rate of acceleration stays the same. The acceleration never changes. The rate of change of velocity, that number's constant, but the velocity itself is constantly changing as the ball goes down. Let's talk a little bit about both directions. To make things easy, I'll roll it off this table. Now, if the ball's rolling at a constant speed, let's just say it was like 2 meters per second, the ball's rolling at a constant speed, when it goes off the end of the table, it's going to be going horizontally at that speed. There's nothing to slow it down. Okay? No forces are acting directly on it. So you can assume this way the velocity is the same. So when I roll this off, this way's velocity is going to be the same. But once the table is no longer there to support it, the object will fall to the ground and it will follow a curved path and land some distance away, like such. All right? So now we have two different concepts. We have a horizontal motion and we have vertical motion. And the rule is you can't mix your horizontal numbers with your vertical numbers, okay? You can't use this velocity or this distance and put it into an equation using gravity, because gravity is a vertical number. And your constant velocity in this case would be a horizontal number. Now, one of the other things we did was walk by and drop a ball into the bucket. Now they give this to test pilots, do this because if you're going to drop something from an airplane, you cannot wait till you're over the target to drop it, because whatever you're dropping has the same speed as the airplane. If an airplane is flying at 200 miles an hour horizontally, everything on the airplane is going 200 miles an hour relative to the ground. So what you had to do was walk, and you actually have to release before you get to the bucket. Okay. As you're walking, the ball has a horizontal velocity, but when you let go, it will follow a slightly curved path into